Okay, here we go with 10.3 notes, the unit circle. So as we've seen, we can measure angles using degrees, but degrees aren't the only way to measure angles. So we're going to talk about what a radian is. A radian is a unit of angle measure based on arc length. Okay? So I want you to go ahead and draw a circle. In your circle, you should have the center of the circle. We're going to put a point there. And kind of like what we've been doing in section 10.2, I'm going to make the initial side of an angle. So remember how an angle will start at 0 degrees. Now, we're going to call this angle theta. And we're going to do the other side in a second. But I want you to think, imagine for a moment, that this radius, we're going to call it r. So imagine you took this radius. And you can imagine you took it out like it's a piece of string. And you just moved it out of the circle. So imagine you took the radius and here it is. Imagine now that this radius is flexible. You can bend it. You can do whatever you want with it. Imagine that you could take it, and starting with this point right here, you put it right here, and then you make this bendable radius run along the circumference of the circle. Now, eventually, you would run out of the length of the radius, and it would have to stop somewhere. Let's say it stops about right there. So what we have here is, based off this length of the radius, this is also a length of r. And if I was to complete this, this would also be a length of r. So we have this triangular shape, even though it's not really a triangle because of the curviness right here. This is not a straight line. All three of these have the same measure of r. And so what a radian is, it's one of these measures right here. So that's what a radian is. Now, I would like to talk a little bit more about what a radian is. I'm going to draw a little XY coordinate plane. So, you know how there's radians and degrees now. You've learned what a degree is, you've already known, and now you know what a radian is. Well, I want to show you how to convert between the two. So, if I was to draw an angle like this is your initial side and this is your terminal side, you know that this is 180 degrees. Okay? Well, in terms of radians, you know how long that is in terms of radians? That is what we call pi radians. Sometimes people just put RAD, or even they don't even write the word radians at all sometimes. They might just say 180 degrees equals pi. So for every 100 degrees that you have, that's equal to pi. So what about a full circle? How many radians would that be? If 180 degrees is pi, well, we know a full circle is 360 degrees. Well then, wouldn't that just be two of these pi's? And yes, it would. So 360 degrees is equal to what we call 2 pi. It's 2 pi radians. So using this idea, here's how you convert between angle measures. If you want to go from degrees to radians, you multiply by pi over 180 degrees. And to go the other way, radians to degrees, you multiply by 180 degrees over pi. So let's do a couple examples. We're going to convert 45 degrees to radians. Well, I just take 45 degrees and I multiply by pi over 180 degrees. Some people, you don't have to do this, but some people do like to put this over 1. And you just start canceling anything that you can. Now, the first thing that you must cancel is the degree symbol. Because you have a degree symbol on top and bottom. That's, the degree symbol is like your unit. And you can just cancel it. Sorry, this is getting a little fuzzy here. Sorry about that. So then those are gone. Also, we have 45 and 180. Because remember, you can cancel diagonally and vertically. You just cannot cancel horizontally. But it looks like 5 goes into both of these numbers. So 5 goes into 45 9 times. It goes into 180. I don't want to make any mistakes on the camera. 36 times. Actually, 9 and 36 have a 9 in common, so I can go a little further here. So this whole thing is 1 over 1, so I don't really care about that anymore. But over here I have pi over 4, and so that's what we get. So 45 degrees is pi over 4. Let's go ahead and do this one. So we have 80 degrees. You can put it over 1 and multiply by pi over 180 degrees. All right, the degree symbols cancel. 10 goes in both of these numbers. Into here 8 times, and into here 18 times. And actually, you can go a little further. You can take a 2 out of both of these. 8 divided by 2 is 4. 18 divided by 2 is 9. So I have 4 pi on top. 1 times 9 is 9. So these are radian measures. By the way, pi over 4 is some number. Where's my pi button on here? If you can find the pi button, and so mine's right here, and do division by 4. So pi over 4 as a decimal is just 0.785 and some irrational, never-ending, never-repeating number. Same thing with 4 pi over 9. If I was to plug it in, I would get some just random decimal going on. So that's what radians are. They're just different versions of your degrees. Now let's go ahead and go backwards. We're going to convert from degrees to radians. You're going to multiply by 180 degrees over pi. We're going to be doing that in both of these, so we might as well just set up both of these right now. Okay, first thing I hope that you see cancels are the pi's. Then 5 over 6 can't reduce, but 6 does go into 180. It goes into 180 30 times. So I have 5 times 30 with the degree symbol. So 5 times 30 is 150 degrees, and I have nothing left on the bottom. So that's what that is. Let's go over here. The pi's will cancel. And actually, that means everything on the bottom is gone. So now you're left with 4 times 180. And I cannot plug into a calculator. So that's 720. And then don't forget your degree symbol. Hey, you know what? 720, isn't that 360 times 2? And that should make sense. If 360 is 2 pi, then 720, which is double that, 2 pi should be doubled as well. And indeed it is. 4 pi was the original problem. All right, now we're going to come to what's called the unit circle. Off to the side right here, I want you to write the word properties. Because this unit circle has some special properties. The first property is that the radius is 1. Okay? So the first property is that the radius is equal to 1. And what that means is, see how the center is right here and here's the circle. Any radius that you see has a distance of 1. Another property of the unit circle is that every point is an XY point, and see how we have room to write these points? We're going to be filling in these blanks, by the way. So be ready to fill in these blanks. Every point is XY, but actually, every point is also cosine theta, comma sine theta. This is such a key thing, and this is something you're going to be using a lot in this section. Okay? So, now, we're going to go ahead and fill in the circle. What I'm going to do is, in the description, hopefully I don't forget to do this. If I do, please remind me to do this. But I'm going to put a filled-in version of this so that you can, if you want to go ahead and pause the video now, you can click the link and fill in the whole circle. However, I'm going to go ahead and fill it in as well, kind of explaining why everything is the way it is. So, maybe you've already filled in the circle now, and I'm going to go ahead and just walk you through what's going on here. We're going to start with the degree measures. Now, we know that in the circle, if this is your initial side, this is 0 degrees right here. And up here is 90. We have 180. We have 270. And also we have 360 degrees. to make the full revolution? Well, these are all the degree measures, and actually there's more. So we have 30 degrees here. So that's from here to here is 30, 45, 60. We already did 90. We have 120, 135, 150, 180. Now, maybe you're starting to see a pattern here. From here to here, this is 30 degrees, and so it is from here to here. So there's a lot of symmetry within this unit circle. So also from here to here is 30 degrees, and from here to here is 30 degrees. So actually I can predict what the next number will be. 180 plus another 30 degrees is 210. Now every one of these smaller ones is 15 degrees wide. So to get from this to this, I'm going to go another 15. 210 plus 15 is 225. Another 15 will give me 240 right here. And the big one's going to be 30 degrees. And indeed, 240 plus 30 is 270. Another 30 degrees will get me here. 270 plus 30 is 300. This is another 15, so this is 315. This is another 15, so it's 330. This is another 30. 330 plus 30 is 360. So now I have all the degrees filled in. Now that's degrees, but I also need to put radians in here. And so what I'm going to do now is, well, one thing you could do is you can convert all these degrees to radians using the formula up here. But I'm going to go ahead and just give you what they are, because I'm not going to spend time converting each one separately. It's already been done, and if you copy down the chart, you already have it. But anyways, here you have 0. That's 0 radians. Here you have pi over 6. You have pi over 4. You have pi over 3. And you have pi over 2. Okay? So now if I keep going and just keep filling it in, over here I have 2 pi over 3, I have 3 pi over 4, I have 5 pi over 6, and over here I have pi. Like we said before, remember 180 degrees is pi. We said that way up here. Okay, keep going. And now I should have 7 pi over 6, 5 pi over 4, and 4 pi over 3. Down here I have 3 pi over 2. Over here I have 5 pi over 3, 7 pi over 4, and 11 pi over 6. And 360 is also 2 pi. So 2 pi is your full revolution. Now, all these points, this circle is also has all these special points. So we're going to go ahead and label all these points as well. Now remember, your radius is 1. So it should make sense that this point right here is 1, 0. Up here it should be 0, 1. It should be -1, 0, and 0, -1. Those should make sense because your radius is 1 everywhere. Now, these have special points, and we're going to go ahead and fill these in now. So square root of 3 over 2, comma 1/2. We have square root of 2 over 2, square root of 2 over 2. And we have 1/2 square root of 3 over 2. All right. Now here's how I think about this. Actually, no, I'm gonna tell you that trick a little bit later. So let me not tell you that yet, because I don't want to confuse you on this video. So now I'm just gonna keep filling this in. Okay, so you should have this all filled in. And we have okay, so that's your unit circle. What is the point of the unit circle? So let me kind of tell you what's going on here. So have this as a reference because I'm about to switch to a new sheet. Now, what I'm about to write on this sheet, you can write on the back of your notes sheet. All right, so one reason why we use a unit circle is sometimes we can find things really fast with the unit circle. So here's an example. We're going to use a unit circle to find the exact value of each trig function. So for example, if I said to find cosine of 210 degrees, what you can do is you can take your unit circle, find 210 degrees. So that's right here. Now remember what I said. Every point, and all these points on the outside, all these points are cosine theta, sine theta. So if I look at 210, and I'm trying to find cosine of 210, well, cosine is just my x-coordinate. And so cosine of 210 is negative square root of 3 over 2. Okay, let's try another one. We have tangent of 5 pi over 3. Okay, so let's go ahead and find 5 pi over 3. So that's all the way over here at 300 degrees. It's 5 pi over 3. Now tangent, we don't tell you what tangent is, so you're about to write a third property here. Tangent theta is equal to sine theta divided by cosine theta. So to find tangent theta, if you need to, off the unit circle, you divide sine theta by cosine theta. Or basically what you're doing is you're dividing your y-coordinate by your x-coordinate. So let's go back to 5 pi over 3. I'm going to be dividing negative square root of 3 over 2 by 1/2. So that's what I'm going to show you right here. So remember, I'm doing, this is what I'm doing right here. Sine of 5 pi over 3 divided by cosine of 5 pi over 3. Okay, well, what's sine of 5 pi over 3? Remember, all points are cosine then sine. So sine would be negative square root of 3 over 2 divided by cosine of 5 pi over 3, which is 1/2. Now look what I have here. I have a fraction divided by a fraction. You need to keep, change, flip. So let's go ahead and do that real quick. So I keep the first fraction, I change this division to multiplication, and then I flip the second fraction. Now look what happens with these 2's right here. They cancel. So, and the 1 doesn't matter, so we can just cross it out. So your answer is just negative square root of 3. So that's tangent of 5 pi over 3. Let's try another one. We have sine of 315 degrees. All right, so we get out our unit circle. We say, okay, sine of 315. So here's 315. Sorry, I don't know why it's all fuzzy. There we go. Now remember, every point is cosine then sine. So sine would be negative square root of 2 over 2. Part D. Let's do tangent of 180 degrees. Let's remember that tangent is really sine over cosine. So we need to look up both of these numbers. So sine of 180 degrees, if I go here, so 180 degrees is right here. Sine is my y-coordinate, so I have 0. Cosine of 180 degrees is negative 1. And 0 divided by anything is 0. So that's what that is. Let's try another one. We have cosine of 4 pi over 3. So 4 pi over 3 is right here. We want the cosine of that. So cosine then sine. So we want negative 1/2. One last one that we'll do is, and I'm actually just going to make this up off the top of my head, is let's go ahead and find cosecant of 315 degrees. This will be our last problem, then we're done. Now, cosecant, if you recall, cosecant is just the reciprocal of sine. Okay? So really, all I have to do is try and find sine 315. Actually, didn't I already do that? I did it right here. So you know what I have to do? All I have to do is take what I know, sine 315, and if cosecant is a reciprocal, I just have to take this fraction and flip it over. So I'm going to take this fraction, because these are reciprocals of each other. Maybe let's make a note of that, actually. These are reciprocals. I take this and I flip it over. I'm going to keep the negative like on the outside like this. So I have negative 2 over square root of 2. Now, one thing is you have to rationalize the denominator. What I mean is you're not allowed to have square roots in your denominator. This is an easy fix, though. All you have to do is multiply the top and bottom by whatever square root you have in the bottom. So I'm going to multiply the top and bottom by square root of 2. So I'm going to keep this negative right here. Now I have 2 square root of 2 on top. On the bottom, the square root of 2 times the square root of 2 is the square root of 4, but the square root of 4 is just 2. Now, so basically the property is the square root of something times itself is just that number. Now what happens with these 2's right here? They cancel, and you're left with negative square root of 2. All right. And there you go.